feeds directly into their waterways. They don't treat their wastewater at all. And communities downstream use this water that has this untreated wastewater in it. And it usually leads to illnesses because of different bacteria and other things in the water because it's not treated. For instance, E. coli, which is found in the water. Malnutrition is also a big problem in developing countries due to impoverishment. Honduras, the country that we looked at to model our design off of, has about 45% of its population currently living in extreme poverty. So for our solution, we would like to develop a system so that we can treat the effluent wastewater to a better quality in a very cost-effective way, as well as introducing nutrition into the diets of the people in the community by growing plants from our treated wastewater. So we got a town in Zacapa, Honduras as our pilot plant. They have a population of about 400 people, and it's a very tropical climate there. They do not have a winter, and they also have very heavy rainfalls in the area. Right now, they're in their rainy season, and they have a dry season in the summertime. So for our design, we will be creating our own wastewater from cow manure, and we'll mix it. About 5 gallons of manure, we'll be able to mix about 100 gallons of wastewater. And this table to the right basically shows the concentrations of a few parameters from typical wastewater, so BOD5, COD, total nitrogen, and it's our goal to mix our wastewater so we can get as close as possible to these concentrations. So for our flow information, the town of Zacapa, Honduras has about 400 people living there, and it's about, for their water usage, it's about 30 gallons per day per person. So including the rainfall in the calculations, as well as about a 30% safety factor, the total flow will be about 121,500 gallons per day in that particular area.
So this is a large-scale process flow diagram.